Hi everyone, my name is Kory Fong, and I lead engineering at Private AI. We are a company that helps you identify and redact your personally identifiable information in unstructured data. And today I'm going to talk to you about how to unlock the value of your data using a privacy-centric approach. So I'll start off by saying, what's your problem? Specifically, what's your problem with your data? And amongst other things, the likely answer to that is privacy. And that is it's quite a prevalent enterprise problem. In fact, a recent study says that 68% of enterprise data goes unused. And usability of data is a big reason for that. Usability is something that is a little bit later. When we say, from a functional perspective, unstructured data is difficult to use because it's often messy. That's why we have data engineers. Well, it's one of the reasons we have data engineers, but that's down there. And if it's functionally difficult to use, how do we know that private sensitive information isn't in that data? From a functional standpoint, it's difficult to use, but also it can have a financial impact if you're not storing that information properly. So before we go any further, I'll put a little bit of context around what personal data actually means, and we use GDPR to help us define that. Personal data, very simply, is any information that relates to identified or identifiable living individuals. Now that's not just single pieces of information, but it also relates to aggregate data that can lead to the identification of an individual. GDPR also goes into, at length, what anonymization means and the processes in which you take to protect that data. Now, I don't mean to throw no shade. This is just an article that happened to come up recently, and it was about the financial implications of not taking care of your data. We'll ignore the details around how the data was gathered, but this is specifically about the storage and usage of private data. As a bit of an aside, I do want to say that I did not know Clearview AI was going to be here, and they had quite a presence. So, my apologies on that front. The other side of it is, I wanted to say that between myself, our COO, Paul Burster, and our head of sales here, anyone from Clearview that wants to come talk to us, we can find something together for you. I digress. So, what's privacy problems actually mean? And the main theme around that is disclosure. And disclosure can come in many forms. It can be a very simple identity disclosure, the fact that you are an individual in that data set. It can mean attributes, descriptions about an individual. It can be about descriptions about a group that an individual belongs to. And it also can say, you belong to a group in general. Personally, I might really enjoy knitting, but I not want to broadcast it to a bunch of people. And privacy is something that we want to care about. This is a really fun anecdote that is becoming a bit of a fun thing. It's not fun for the folks in the data sets, but a South Korean chatbot company training their chatbot on production data, sensory production data, ends up having being susceptible to a disclosure attack. So disclosure attack being when I start interacting with this chatbot and I give context around a particular individual, it'll actually return names, addresses, in one situation, a specific salary about an individual if you were to pass them their name. Pretty scary stuff as a result of not taking care of how you train your data or how you train your models. So let's get to the meat of things. What can you actually do? And that's the theme of this. We want to build a privacy-centric approach to how you handle your data and your workflows. So where can you do that? There's four obvious places. You have where your training data lies, where your input data lies, your model weights, and obviously your output data. The most effective places we can talk about are your training data and your input data. And those are the solutions that we're going to go over. So, a lot of you have probably heard of the term differential privacy. This is the one of the mathematically concise definitions. I'll leave the high level. The high level is we are taking noise and adding it to a data set and that provides a mathematical guarantee of privacy. For anyone who actually does want to dive into this in detail, I did not have an appreciation of how technical this crowd was. I naively assumed that everyone here was going to be a business person, so I just left it at high level. But for anyone who wants to geek out and talk about this in detail, happy to do so. Please come to Google tonight. Now, differential privacy. It's a great technical solution. And again, it provides you a mathematical guarantee of the worst case scenario. But there are two strong cons to that. The first one is utility. If you have an underrepresented group in your data set, it will have a heightened effect on how you introduce noise to that data set. The other side of that problem is the expertise requirement. Differential privacy is not just a tool you take and say, well, I'm going to use that in the data set, and you're fine. Differential privacy, the way you introduce it, has, based off of the data set and parameters of your data set, it basically needs to be a bespoke introduction to that data. If you're not doing that properly, it might be useless for inferences in data, and it might be useless from a privacy standpoint. So the parallel I can draw here is you wouldn't take a regular software engineer and say, well, I'd like you to implement this cryptographic primitive. The answer to that question is you do not do that. In that same vein, you don't take data scientists and say, well, just introduce some differential privacy. So what's another solution? There we go. All right. We can redact or de-identify your data. Now, this first approach, you take a look at production data and what it looks like in de-identified format. If you want to build into your workflow the ability to re-identify the data, right now, you're able to separate the context from the identifiable data. And without context, a lot of the direct identifier or quasi-identifiers are benign or much less dangerous on their own. If, however, you need to use the data and retain the context for things like sentiment analysis or for entity recognition, you can introduce contextually accurate synthetic data. And, well, this being one of those scenarios. So you're not just introducing random entities, but you're introducing entities that have relations to the other entities found within the context. That can continue to allow you to prevent downstream model accuracy loss for those training scenarios. It also helps you combat the risk of re-identifiability and rejoinability in your data. So we were talking about this. Direct identifiers, not quite the same. Context is the one that's important. Now, I'm really done with this on time. Good. Well, that's perfect. This was the second last slide. Now, you're not meant to actually read this. This is just trying to summarize everything by saying we have plenty of expertise at Private AI on how to tackle the problem of privacy and privacy in your data. We are not, we will help you with bespoke solutions to your problems, and we put a lot of thought into it. So I would gladly encourage you guys to come over to booth 109, have a conversation with us. We would love to help you with your privacy problems. Go ahead.